All right, this is going to be some videos for the regression analysis. Okay, so here is regression. And the purpose of regression is to take a line, or not take a line, but take data. So let's suppose we want to look at the relationship between using fertilizer on your farm and the amount of yield of your product that you get. So what we want to do is ask different farmers how much fertilizer they used on a given patch of land and how much yield that patch of land produced. So each of these data points is going to represent a farmer that we ask the question to. So we ask the question, how much fertilizer did you use? He says, I used this much. And then we ask, how much yield did you get? I had that much. So that's the relationship we get, or the data that we get between these two. And now the question we want to ask is, what's the relationship between yield and fertilizer? And as we see the data points line up this way, it's almost as if we could draw a line right about here that describes that relationship. And that's exactly what regression analysis is designed to do. So regression analysis is designed to draw a best fit line that represents that relationship. Now, before we described a line as y equals mx plus b. And that's going to be the same concept here. So here we have b, which is our y-intercept, and here we have our slope, which is m. But we notice here that there's these differences between the dots and the line. So this isn't quite sufficient for what we're going to do with regression analysis. We want to write it generically as this: y equals beta naught plus beta 1 x plus an error term, which we'll signify by u. And what that means here is, instead of b for our y-intercept, we're going to write beta naught, and instead of our slope, we're going to write beta 1. So to write out the model, so this is what we call our model. Our model is going to be yield equals beta naught plus beta 1 fertilizer plus u. And the reason we have this plus u is because there's other things that affect the yield that's not fertilizer. So the amount of precipitation the land receives, the amount of water in the same sense, amount of sunlight, the quality of the soil, all these things are going to also affect yield, but we just want to find the relationship between fertilizer and yield. So that's where we get now our interpretation. So if we want to interpret beta naught, well, beta naught again is our y-intercept. So it's going to be when fertilizer equals 0, how much yield should we expect to get? So this is the average yield when fertilizer equals 0. All right. Next is, how do we interpret beta 1? Well, beta 1 again is our slope, which is the change in y over change of x. So it's going to be the change, so I'll use delta, in yield for a unit change in fertilizer. And it tells us how much will our yield increase for each additional unit of fertilizer we get. And so this is the purpose, the point of regression analysis, is to take our data points and apply a best fit line to represent that relationship between two variables, yield and fertilizer.